All right, let's get the show started. Hello, everyone. Thank you all for joining. Welcome to InRhythm Lightning Talks. I'm your host, Parag Katkar. I'm the head of consulting practices at InRhythm, and we have a lot of exciting talks lined up for you in the upcoming weeks. Our Lightning Talks are hosted every Thursday at 5:15 p.m. Eastern Time, and each week, one of our practice area consultants shares their knowledge on the evolving technology trends in the industry that will help you keep learning and growing in your career. So this week, Josh Espinosa, who is a senior software engineer with us, is going over unit testing best practices, and I'm super excited about this talk. So without further ado, let's get it started, Josh.
Thank you, Parag. Hi, everyone. My name is Josh Espinosa. Like Parag mentioned, I'm a senior software engineer. I've been working for InRhythm at MasterCard for over 2.5 years. I've been a software developer for over 6 years. Today, I want to talk to you about unit tests. As you may know, unit tests are highly valuable, so we need a lot of them. However, they take a lot of time to write and even more time to maintain. Unit tests are often prone to false positives and negatives, and people tend to either test too much or too little. If you test too much, you're kind of coupling usually to your implementation details, which increases, maintenance costs. And if you're testing too little, then, you won't catch some side effects or bugs. So today I want to talk to you about how we can reduce those maintenance costs for the tests while writing the tests in a way that, instill confidence when it comes time to refactor, as well as creating an environment that's conducive to, encourages refactoring. Additionally, by doing all this, you'll realize that unit tests are more of a boon. They can aid developers in writing bug-free code rather than being a hindrance, a chore, just something to increase that percentage number in the coverage. So we can do this by this concept, testing by contract, also known as testing the public interface. So what is a contract? A contract is an agreement to carry out some task. All code has a contract or a purpose. And it's important to start seeing your code in this way, like as a series of layered contracts. And in doing so, you'll see how everything kind of functionally connects to each other and what components are valuable to, this will help in organization and also for your tests as well. Let's work through a simple example of a contract. So let's say I had a birthday party coming up and I want to place an order for a cake delivery. I might place a phone call to a bakery. I'll tell them the details of what I want. I'll give them payment, over the phone. And then come Saturday, I expect cake, right? So in this way, I don't really care, how I get the cake as long as I get a cake by Saturday. I don't care if the bakery had to go to the store and buy additional ingredients. I don't care if they had to call their friends, for help. Let's say they were shorthanded. I just care that I get the cake at the end. So in this way, we can kind of just black box this middleman, and so we're only concerned with the inputs that I called them by phone and paid, and the outputs that I received the cake. So it's important to see, your code in this way as well. This is basically the contract. Given these inputs, I expect this output. So let's see how we can apply this to code. Here we have a Vue single file component. And if you're unfamiliar with Vue, it's basically just some HTML on the top and some JavaScript at the bottom. Here we have a simple button wrapper that, when clicked, emits the CTA click event, which is then handled by this do something function. This do something function then sets this result data property to the result of this mock API call, which is just returning a string for this example. This result is then shown in this div container. Right, that was a lot of verbosity for just saying that when I click on this button, it shows something on the screen, right? So let's keep that in mind as we look at how someone might approach writing tests for for this file or for this button before and after using the concept of testing by contract. So often what people would do is they would come into this file, they'll say, okay, there's this function called do something. What is it doing? It's setting this dot result, this result data property to the result of this API call. So that they'll just kind of look at that, kind of tunnel in on that, and then write, kind of mindlessly almost write exactly what the code is doing. They'll write a description, test description saying, when do something is called, it should set the result properly, right? So there's a, okay, so let's go through this test really quick and then I'll talk about it. So this test is first shallow mounting this file, this example. And if you're not familiar with shallow mount, it's basically isolating this module and testing the instance of this module and kind of stubbing its external dependencies, which in this case would be this button. It's a child component, so it will just be stubbing that out. This way, we can ensure that we're testing this module in isolation. Then this test will call this do something function or this method directly, and then just assert that it is properly setting this result. Right, so this works. It is testing the functionality of the do something function. However, there's a lot of things wrong with it. One of the main issues when it comes to maintenance is that it's tightly coupled to implementation details. Here we can see we're calling the function by name, do something, and we're accessing the data property by name, right? So if we were to come into this code and change this function to something that makes more sense, like fetch users or what have you, or change result to like response, we would have to come in to the test and then make those updates as well. So this might seem like a simple, this might seem simple for now, but this is just an example. But imagine hundreds or thousands of tests and having to make these updates all the time. It can be pretty tedious, and it's not always as simple as global find and replace. Additionally, this test description is simply listing out what this test is or the code is doing, right? It's just listing out exactly what you can read here already. This is already self-documenting. It's calling do something and expecting this result to be something. You don't have to, like, this description is pointless. Additionally, so when we look at the the big picture, excuse me, when we look at the big picture of this button, we know that it's this process starts. Excuse me, one second. This process starts when the button is clicked, right? The user clicks on the button, and then everything else kind of happens, right? The do something function is then serves as the handler, and then it sets the result. But the important thing is that the result is then shown on the screen later on. Sorry about that. So in a way, this test is testing the is testing the middle, right? Oh my God. So the ultimate beginning is that the button is clicked, and that the very end is that it's shown on the screen. This test is testing in the middle. It's testing that the function is called and that the result data property is set, but it's not testing how this function was called to begin with, why and how this happened. It's also not testing what happens to this result and that it is displayed on the screen in this container. So this tends to be the case, and what you might not immediately think to test the DOM, because you'll see, okay, this is like a non-visual test. There's no like browser that I'm like looking at. So you might intuitively think I just need to test the JavaScript. Later on, you might come to realize that that's not the case, and that you do want to, make sure that the content is rendered appropriately on the page. So then what I usually see happen is people end up filling that gap with snapshot tests. They end up just writing tons of snapshot tests, but snapshot tests are great, but the problem is they're often overused. When there's too many snapshot tests, anytime you make a change to the template, it'll just trigger a bunch of snapshot updates, and it just becomes like hundreds of snapshots. It's too tedious to look through, so people just assume that they did the right thing, and then they press the U button. They update the snapshots without even looking at them. At that point, when you stop looking at those snapshot tests, they become useless. So if you want to use snapshot tests, what I would recommend instead is to create, to have like maybe one snapshot test per major structural or skeleton change. Capture the initial skeleton, and that way, with one snapshot test, and then test the rest more granularly. What this will allow you to do is, when you see snapshot updates, you'll know, okay, these are the important snapshots. I should definitely at least check those out. All right, so let's look at what it would look like after using this concept of testing by contract. So here we can see immediately that test description is a lot clearer. When the CTA button is clicked, it should display the result on the screen, right? That's what I said originally. The long story short was that you clicked on this button and that the result was displayed in this container. So that's exactly what you should write as a test description. What often helps me when I'm trying to think of what to write for a test description is, imagine I'm talking to a junior developer on the team that's familiar with the project, but not the module that I'm testing. And that's often a good, kind of guide to write good test descriptions. And it's important to remember that test descriptions are documentation as well. By reading this test description, you should, be able to identify the contract, and also like identify like, what it's guarding against, or what like either it's guarding against some bug or it's asserting some correct behavior. So it's important to keep that in mind and make sure that the test descriptions are being put to good use. Okay, this test is then also doing the shallow mount. And then where it differs here is, instead of going directly to the function, it's going to the source, right? So it's going to the button's stub, because remember, this is being shallow mounted. So this button is, this child is being stubbed, but using view test utils, and I'm sure there's similar ways to do this in any, in any framework, we can simulate an event being emitted from the child. So in this case, we're simulating the CTA click event, which will then trigger all the rest of the flow. And then at the very end, we're just asserting what we expect the application state to be in at the very end, which is that this result is contained in this container. All right, so this is great and all, but it doesn't always make sense, right? To test by contract, testing by contract is always important, but how much you black box can vary, right? Or how much you black box should vary. Because let's say the do something function had 10 different paths it could take. Let's say that each of those paths depended on various API calls, third-party libraries, reactive data, getters. It might be really difficult to go through all those flows by just changing the inputs, right? So you end up needing to mock like all the responses in between to make the path kind of go the way that you want it to go. So when you end up having to do that, sometimes you end up spending way too much time. Maybe the mocks are just really complex. The packages aren't set up in a way that's easy to mock. Like all these problems could happen, and it may be wasting your time, right? So when you think that maybe you're spending too much time on setting up the test, you should think about a couple of things. One, am I saving time by doing this, or would I have just saved more time, just updating the test directly, every time a change was made? Maybe that would have been less trouble. Additionally, can this test setup be reused? If it can be reused, like let's say in other test suites throughout your application, then it might be worth the time investment to build that like setup data. So this is something we do at MasterCard. We have a file for general test setup that exports this factory function that we can use to kind of build the bare bones of the bare bones instance of the wrapper, and then we can use that to test the rest. So what the factory function does is it sets up all of the stubs, all of the mocks, installs some common plugins, and then it spits back a wrapper that we can use. Another thing is that whenever you are making these concessions, right, whenever you're drilling down from the larger black box to go closer to your implementation details, that's usually an indicator that, like, and what I mean by drilling down into the implementation details is, for when there's a complex flow like the 10 different paths like we mentioned, you might want to instead just directly invoke the function with the correct data rather than trying to do it at the very ends of the input and output, right? So anytime you do that and drill down into the implementation details, you have to just remember that you're adding maintenance cost to that test in the future. But what this tells you is whenever you make these concessions to to sacrifice the larger black box for, faster, coding or faster tests, this might be an indicator that the code can be refactored, right? So maybe it's violating the single responsibility principle. Maybe you can split up your code to more logical chunks, or add abstractions or remove abstractions. There's a lot you can do. So it's usually a good, I guess, code smell. But until those refactors happen, you do need, you still need the unit tests to be there. And so this is how you could do it. And in general, that's what I would recommend. If you are trying to refactor something, ensure that there's good code coverage, test coverage first. This isn't, I don't mean just unit tests, but also the other forms of testing as well, such as integration tests, API contract tests, automation with different devices and so forth. And when I say, good coverage, I don't mean 100% coverage. 100% coverage, you often hear is bad, or it's something that you shouldn't aim for. But it doesn't mean that it actually doesn't mean that it's bad to have 100% coverage. It just means that you shouldn't over test, right? That's the main point of it. So what I mean is, oftentimes the core functionality of your component can be tested with those inputs and outputs. But when you find yourself calling functions in the middle just to test one particular thing to add coverage, you have to ask yourself, is that worth it? Is it important? And, and also, is it worth the maintenance costs that'll come with that test? Because then you're coupling to your test implementation details. I mean, the code implementation details. So, I would recommend writing your tests in a way that, encapsulate, capture the primary functionality of your application, the contract of each major piece of functionality. Make sure you're testing some edge cases, some reasonable edge cases, right? Not you don't want to over test it and test every single possible type of input. You might as well just be using TypeScript at that point, which is recommended, of course. But just test reasonable inputs and outputs, and don't overdo it. All right, so we talked a lot about the contracts within a module, right? So the code within a module, its purpose, there's different contracts and they interact with each other in an isolated environment. There's also each module has a contract innately with its surrounding context. So for example, let's think about UI components like we looked at earlier, that single file component. The modules like that usually have a child and maybe a parent. So for Vue.js in particular, you could test that the module is emitting the proper events to the parent, and that the module is passing down the proper data to the child, via props. So in doing this, by focusing on the contracts within a module, you're ensuring that it's well tested within. And then for the inter-module contracts, you're ensuring that it has connectors, to its, to whatever it's plugged into, to its parent and child context. So there's other types of boundaries as well. So your module, it has boundaries within the repo, within your application, and then it also has boundaries with external dependencies, such as third-party libraries. For those, you often want to mock them completely, so that you're not testing their code, right? So if you install some package from GitHub, from npm, you should assume that those packages are well tested and they have their own test suites. It's not your application's job to test their code, right? So you should be focusing on your code and then mocking all the external dependencies. That way you can test your code in isolation. And in doing all this, ensuring that, within and without your module, that the contracts are well tested, you can gain this sense of confidence when it comes time to refactor. Like we mentioned before, when you have good test coverage, then you can refactor, and then if something breaks, you'll know that you're not, it's catching those potential bugs or regression issues. So you can refactor with less care, and then just fix the tests, and you'll know that everything should still work. So that's kind of the point of tests, is to catch for certain bugs, and then also give you this certainty and this confidence later that you don't break anything that you already fixed. All right, so I want to talk about a couple additional tips. There's plenty of best practices when it comes to unit tests, right? I can't talk about all of them right now, but I will focus on two of them that I think are really important. The first one is to make your tests fail. So this might seem counterintuitive, but it's really important. And the reason being is this helps prevent false positives and negatives. You could have a test that's always passing, and you wouldn't know, you wouldn't even realize for a long time, maybe. You could, some ways this could happen, for example, is if you're mocking everything. If you're mocking too much and you don't realize, you could just be testing mocks, right? You might not even be testing the code anymore if you're mocking everything. So sometimes we don't realize, especially if there's like a long test suite and you have lots of mocks being set at different states and like before each and in every nested block, and then you can quickly fall into this trap without realizing, and then the bug could slip through. So in order to prevent this, you could. So basically, when you write a test, think about what the test is actually doing, right? So what is the purpose of this test? What is it preventing? Like, what is it capturing? Sorry, what functionality is it asserting should happen? And then what bugs is it guarding against? So let's say if you're asserting that, something should happen when something else has happened, then just like go into your code and break it. See if the test fails. Does your test catch what it's supposed to be looking out for? Another way you can do it is, in your test, if you have a step that should happen before your assertions that make it true, you can comment that out and see if the test fails now, right? So by doing this, you know that you don't have a false positive. So, it might be tedious to do this all the time. So usually what I do is I write what I call opposite tests. And I hesitate to use the terms, positive and negative tests, because it seems to vary from person or team to team. But what I mean by it, and the main point of it, terminology is not really important, is like let's say you had a test that when you do something, you're asserting that a function is called. An opposite test would be right after it, you could test when I'm not doing that something, the function is not called, right? So you have kind of the reverse side by side. So that pair of tests kind of captures the false positives, or prevents false positives and negatives between them, those two. So that's a good practice to have, but sometimes it's not always possible to do that, because sometimes there's kind of one way, like one directional, state changes that doing the opposite would just be doing nothing, right? So in those cases, sometimes it's useful to manually make your test fail just to make sure that you're not going to cause some false positive. So this also borrows ideas from test-driven development. If you're unfamiliar with what that is, basically it's, you write a test, you assert the test fails, then you fix the test, and then you refactor, right? And then you add another test. So it's this whole concept of writing tests before you write code. But if you're like me and, my brain doesn't work that way, so what I often do is, it's just a different point of the cycle. I write my code first, then I would write the test, assert the test passes, then assert the test fails, and then refactor, right? So after we have tests, we can do the refactoring. That's how I see it. And in this way, it kind of follows the way my brain works, and I'm ensuring that I'm also capturing, or preventing any false positives or negatives. All right, so my second tip is to isolate the important bits. What I mean by that is this goes back to the concept of making your tests robust enough that you don't need to constantly maintain them. So let's say you're asserting that a function is called with specific data, like let's say a consumer object with the first and last name. And let's say your function only cared about the first and last name. It didn't care about any of the other properties in that consumer object. So what you can do is you can just do exactly that, right? Just test only that that object contains the data that you want. So you can do this with a partial matcher, like in Jest, they're called asymmetrical matchers. You can do this, expect that the object is containing the first and last name, right? That way, if additional properties are added to that consumer object in the future, especially if you're using that consumer object, a mock consumer object like across multiple test suites, then you wouldn't have to come and maintain this test, right? So basically, the most you can save time in the future, like not need to update this test, then the better. And this also goes, this is also true when you have, like, let's say a function that has multiple steps, right? Like it's doing a lot of things. It's calling analytics, it's clicking this button, it's calling this action, setting this mutation, but let's say your test description just says, when I call this function, the test mutation was invoked, right? So you don't have to put all the other steps in your unit test. That test should kind of match what the description is saying, right? It should match the contract of the unit test. So then you can kind of remove everything else. And what this does is, let's say you changed the analytics call, right? It wouldn't break your test on the mutation because it's not irrelevant to the test. You should, kind of separate your test that way so that when one thing breaks, it doesn't break everything. It's just breaking the one thing that should have captured that. All right, so in conclusion, it's important to always be actively thinking about what you're truly testing. We often get lost and, caught up in obscurity. We often, we're just looking at the code and then we're just kind of mimicking those steps in the test and just not even thinking about it, right? So if you're constantly thinking about, like, what are you actually doing, like the big picture of, what your code and what your test is, what your code is doing and what your test is testing, then that'll help you make better decisions. It'll help you organize the code better, and it'll help you write more robust tests. And where you're drawing the border of this black box, it's important to remember, is it valuable to me? Is this going to actually save me time, or am I just doing it because some guy in a lightning talk told me to, right? Like, you have to keep that in mind constantly. Consider the trade-offs, and especially if you can reuse something, then it might be worth the time investment, right? But if you're spending too much time on like one thing for like one specific part of your application, then it's probably not worth it. Additionally, we want to make sure that the tests are valuable. We're not over testing. We're not aiming for 100% coverage just for the sake of improving that number. And to verify that those tests are actually breaking properly when the code breaks. And in order to do this, you have to be able to see your application and your code as these series of contracts. All of these interconnected functional components that work together to the larger picture. Being able to define that helps, others when you have it in your test description. It serves as documentation and so forth. And it also helps you organize your code to better suit those contracts. So that is the bulk of my lightning talk. That is my lightning talk, and here are some useful links for further reading if you'd like. Pragmatic Programmer is a great book by Andy Hunt and Dave Thomas. I consider it like a developer Bible of sorts. There's many different chapters, and you can read them in any order that you want. I highly recommend the Design by Contract and Code That's Easy to Test chapters, which highly influenced this talk. And here are some Vue-specific resources that I always recommend people look through when start working with Vue.